end of the lesson, you should be able to compare IDE, SATA, and SCSI technology. Explain what RAID is and what it's used for. Discuss the features of different controllers and identify a graphically rendered image. Oh, hello again. Welcome back to our IT series on hardware and system software. Now, in the previous lesson, we learned about sockets, slots, and ports provided by the motherboard to connect peripherals like a keyboard or a video camera. And we discovered that for each component and each device, the controlling circuitry, called the controller, is either built into the motherboard or into an expansion card that provides a port. Today, we're going to investigate connecting a peripheral device found inside the case. Yep, you guessed it, the hard drive, which is used for secondary storage. Then we're going to join Morwa and Kamo as they go shopping for controller cards that are linked to peripheral devices found outside the case. But let's start with the hard drive. The earliest hard drives had their controllers on expansion cards and used parallel communication. This presented a few problems. Different hard drives needed different cards. So, if you bought a second hard drive, you needed to use another one of the expansion slots, leaving fewer slots for other cards. There were problems with compatibility too, because cards were not always made by the same people who made the drives, and you needed to set switches on the motherboard in order for the drive to work. On top of that, you had to be careful which of the two connectors you used on each cable in order to boot from the one that held the operating system. The first new development in hard drive technology was IDE, or Integrated Drive Electronics. Now with IDE, the controller card is fixed onto the hard drive. From IDE, the next advance was ATA technology, which also uses parallel communication. At the same time, controlling circuitry began to be built into the motherboard, and selecting a drive to boot from was made a lot easier. The name ATA is still used, but these days IDE is used to refer to any hard drive technology using a built-in parallel controller. Obviously, parallel communication, sending more signals at the same time, is a lot faster than serial communication, sending one signal at a time. So, why did they bother to improve on what was already available? Well, the problem with parallel communication is a thing called crosstalk. Crosstalk is when two or more electrical wires lying very close together interfere with each other's current or signal. This can cause data to be lost or corrupted. Now, the race was on to improve the speed of serial communication, and the clear winner was serial ATA, or SATA. Now, SATA technology transfers data a lot faster than IDE, and it's a lot more reliable. Another type of connection for hard drives is SCSI, which stands for Small Computer System Interface. SCSI is a fast, reliable bus that's been around for more than 20 years. Not bad for an old bus. It can connect a lot of different kinds of devices to the computer at the same time. It includes hard drives, scanners, CD-ROM read-write drives, and printers. Sounds a bit like they were trying to invent a universal parallel bus, or UPB. While serial ATA is used for hard drives inside the computer, SCSI is still a popular choice for other devices, including external hard drives. One of the reasons is that devices can be daisy-chained to each other from one connector to the PC. Each SCSI device also has a SCSI port to plug into the next device. You might also come across a motherboard with a built-in SCSI controller. SCSI is often used to control something called RAID. Sounds more like something that's in a war zone than in computer technology. Now, RAID stands for Redundant Array of Independent Disks, and what it means that it allows for a whole bunch of hard drives to be treated as one hard drive. So, the SCSI daisy chain is several hard drives in a row. Now, the speed is very high because these drives can read and write at the same time. RAID is also useful for ensuring critical data doesn't get lost. Now, for this, it uses a technique whereby it keeps an entire copy of a hard disk on another disk, or it spreads that data across a range of disks. At the highest level of RAID, if a hard drive fails, the data on it can be fully recovered from the other hard drives. Now, some motherboard manufacturers have IDE or serial ATA-based RAID controllers built in as a cheaper option. Now, this saves the expense of buying RAID software or SCSI controller cards. Well, I think that just about covers everything we need to know about hard drives. Let's go and join Kamo and Morwa on that shopping trip.
So what time is your mother fetching?
She said she'd SMS me when she's finished shopping.
Great, let's go check out the computer shop.
Great. Look, this laser print says USB. I couldn't find anything that says FireWire, but this says IEEE 1394. That's FireWire, isn't it?
Yep, it is.
And these? It doesn't say anything about how to connect them.
There's sound equipment that uses USB or FireWire. The fitting is standard for all normal audio devices. What we have to look for is the controlling circuitry, because if you plug your speakers into a built-in audio port, you'll have to be stuck with what the motherboard can offer. And that's when you have to go shopping for a good sound card and a special software.
Oh, like the software that compresses a CD song into a file 1/10 of its size and calls it an MP3 file. How does that one work, by the way?
What happens is they just wipe out the sound that can't be heard by the human ear. Now, because it can't be heard by the human ear, they use a software and a computer to do the job. Come on, let's go check out some graphics cards.
Okay. This one says PCI Express. It's good, isn't it?
It's the best. It's the one I want.
Careful, you're drooling. It does look cool. But what's so good about it? What can it do?
It's got a very fast GPU. That's a graphics process card. And lots of video RAM.
It can't tell you how to get the money to buy it. This thing costs more than a brand new computer. And what is the right motherboard?
It's the one that's marked SLI or Crossfire ready.
Oh. So that's what ready means. The motherboard uses a controlling circuitry to make it work. When I'm rich, I'd love to be able to watch TV on my computer. But which is the right one? Which one would you recommend? The one that says video?
Video and graphics cards are the same thing. They can only send output to a TV. They can't receive signals from TV channels. What I mean is what you would do or need is a TV tuner card or a TV tuning device that plugs into the USB or the FireWire port. Now those cards can receive digital satellite signals.
Ooh, I'd better go. My mom's waiting for me at the coffee shop. Okay.
Right, check you later.
Now, did you notice that the graphics cards that Kamo and Morwa were looking at have their own processor and RAM? Now, could you think why this might be necessary? Well, a flat screen is two-dimensional with a height and a width. Now, you might remember that a pixel is one tiny dot or picture element on the screen. So, the more pixels you have, the better the image. With a resolution of 1024 pixels across and 768 pixels down the screen, you have 786,432 pixels on your screen. Graphics cards are used to display 3D images on a two-dimensional or 2D screen. These images are created by graphics designers using a technique called graphic rendering. They show depth, shape, form, and texture. They also show objects that appear to be far away or near to the viewer. Graphic artists start with a wireframe model of an object drawn with triangles of various sizes. As can be seen with this triangle, just by adding two lines, you have what looks like a pyramid. A graphic artist's models are made using hundreds of triangles of different sizes to make a 3D shape. Then, they fill in the pixels in the triangles and over the lines. Each pixel is colored to form a skin over the wireframe model. This is called rasterizing. More objects might have to be created with the pixels altered to show, for example, one object partly obscured by another, or seen through it. Then the effect of light on the object and the shadows created by one object on another are created. Different objects must be given different texture effects. The settings for each pixel and the instructions for drawing it are stored as binary digits, so there's a great deal of number crunching for the GPU to do. And it takes a lot of RAM to store the picture that has to be put onto the screen. Also, the minute you show any movement, another image must be drawn. And on a CRT monitor, the picture must be refreshed about 80 times a second, or the screen will seem to flicker. So gamers and graphic designers need high-end cards and excellent software to handle rendered graphics images. And on that note, I think we should end today's lesson. So, let's quickly summarize. Today, we looked at the differences between IDE, SATA, and SCSI technology. We discovered that RAID controllers use several disks as one disk and are used to prevent critical data from being lost. We also investigated the features of other controllers and found out why a graphics card needs its own GPU and RAM. Now, for today's task. Draw up a table to show the differences between IDE, SATA, and SCSI controllers. Your table must show whether the communication is serial or parallel. Is the data transfer slow or fast? Which devices can connect? Is the controller built into the motherboard or on a card, or both? Can the controller handle RAID technology? Then, when you've completed the task, download some free graphic rendering software from the internet. Then at the end of the term, hold a competition to see who's the best graphic designer or artist. So until then, you've got plenty to be getting on with. I'll see you next time. Bye.